We're going to start this chapter with a lot of review things from basic science courses that you've probably taken in previous years, just bring it up to speed to our level to make sure that we're all on the same page. The scientific method is a series of somewhat steps that are going to solve a problem. It's going to do a lot of scientific experimenting through this process. We're just going to walk you through each of the orders, and every book might word them differently, but their overall is a somewhat consensus of how to approach a problem to solve it. So the first thing in the scientific method is if you want to solve a problem, you kind of have to recognize that it's there. So this might be a step that is sometimes observation. Other books I've seen it as defining a problem. Asking a question, sometimes it's probably a little bit more on the elementary side, but we're just trying to bring you up to what I would consider to be a 10th grade idea. So you make that observation, and before you go through all the steps to see if there's actually a reason to do all this, you do some research. And that's going to potentially give you, well, someone's already done this for you, so you don't really have to go any further. Or there might be some background information that's really important in order for you to take it to that next step. So here's an observation that I have kind of put down here. And before you are going to do research, after you do research, the third step, which is unfortunately a lot of times when I ask this question, what's the first thing that you're going to do? A lot of people or students in front of me will kind of say, make a hypothesis. But you got to think logically. Before you can make a hypothesis, you're going to have to do some of the first two steps. So most often the first two steps are the ones that are missed if anybody asks you for the steps of the scientific method. So you may want to make a note of that. So you have defined hypothesis very early on in your school career as an educated guess. Unfortunately, that is the last time you'll ever use that. We are going to go away from that very simple definition. It's really not going to be considered any longer a guess. We're going to define it as a very key, it's a testable. So you have to have the ability to run a test on it, so that's an important word, and it's an explanation. We're going to go through how to word hypotheses. Sometimes teachers and textbooks will kind of word it as a question. I'm not really a fan of that. We're going to do more of an explanation, a testable explanation for a set of observations would be a good definition for my class for a hypothesis. So Roger has observed that students who take honors classes in college are less likely to drop out of college than students who do not. There are three versions of a hypothesis that we're going to practice writing. So what we do is we have them listed here as a general hypothesis, a directional hypothesis, and a measurable hypothesis. You don't have to write them in this order. I find that some students find it easier to really start with the directional, and you'll see why. We'll start with the general hypothesis, and I'll write it, and then we'll analyze it as to what makes this a general hypothesis. There's a correlation between taking honors classes and the college dropout rate. This came somewhat directly from this information about Roger. So let's analyze why this is a general hypothesis. All that he is saying up here, he recognizes this is the data, this is the observation that he has. So to make a general hypothesis, notice that this says there is a correlation between taking honors classes and the college dropout rate. You are probably already thinking, because of prior knowledge, that what the direction of that correlation would be. But in this hypothesis, if you didn't have any background information and had no preconceived notions, you wouldn't have an idea of how these two actually relate to one another. You would see that there is a correlation. That means there's somewhat a cause-effect relationship. That's what makes this general. I know there's a relationship between taking college courses, honors classes, and the college dropout rate. I do not know if one helps or hurts the other. So it doesn't give you any specific expectation. It just says that there is a relationship between these two. So that makes this a very general hypothesis because it does not show the specific relationship between the two variables. As opposed to the directional relationship, which I'll kind of right here, it says students who take honors classes are less likely, and I'm just bolding that to kind of prove a point, to drop out of college. Now the wording's slightly different. That doesn't have to be verbatim from one to the other, but you get the idea here that once again, it shows there is a relationship between taking honors classes and dropping out of college. But now we have seen that it says are less likely. So now you take it to that next step that says, yes, taking honors classes will decrease your chances of dropping out of college. Going back up here, that doesn't mention that. All it says that there is some relationship. It could have been potentially that there was a higher or lower dropout rate. Let me see, making sense right here. So the correlation between taking honors classes and the college dropout rate. So here it says is less likely. This could have been, in a general hypothesis, it could have been more likely, and I would have actually agreed with that. I just needed to find that there was a correlation between it. Here, the correlation, in order for you to agree with your hypothesis, which you will do later on, there has to be a less likely chance. So what has to happen is there is a less likelihood that you're going to drop out of college if you take honors classes. So what makes this directional? There is specifically a direction, and it's why it's called directional. I can't really avoid using it, but it tells you a specific direction in which the two variables are related to one another. The third type is measurable. So I'll type in a measurable an example. So here I'm going to write 85% of students who have dropped out of college have not taken an honors course in college. So what this states, and I hope it's pretty obvious here, that measurable includes some type of measurement. This number right here is what makes this a measurable hypothesis. So there is a standard value that's put onto the relationship between dropping out of college and taking honors courses. Less likely, it doesn't give you an exact number. It's a very subjective. It could be along the gamut of a long idea of how is less likely. But measurable, it gives you a specific number. So when we look at these three, and we'll revisit the purpose of a hypothesis, it kind of gives you that idea of what you're doing. And later on, after you run your data and look back at it, we then go back and decide, did our hypotheses, do we agree with them from our original statement, or did we kind of prove that they're wrong? But we'll revisit that once we get through the steps. So the third, once you have your hypotheses written, you're going to design a controlled experiment. And that's what we most often do in biology, is a controlled experiment. Sometimes you can't do a controlled experiment, but in this very intro course, we're going to do a controlled experiment, and you'll understand what that means in a few seconds. A controlled experiment has two groups to it, a control group and an experimental group. A control group is a comparison group. So the purpose of this in the experiment is to kind of see what your original or somewhat standard experiment would prove. So a comparison group given no treatment. So the purpose of running an experiment would be to say, what does this specific treatment do to the outcome? The experimental group would be the group that receives the treatment. So we'll run through a variety of examples, but the experimental group, in order to understand that, you have to understand what is called an independent variable. Some books call it the manipulated variable. The reason why they call it that is because the experimenter has the ability to manipulate this variable in the experiment. The dependent variable is kind of what goes hand in hand with this. So the dependent variable would be the responding variable. Changes in this variable are due to the manipulation of the independent variable. So this experimenter doesn't really have control over this. This is what they're trying to see what happens. If I control this, if I manipulate it in any way, how does this respond? And that answer is somewhat going to relate to our hypothesis. If I manipulate taking honors courses, how is that going to change the college dropout rate? So the easiest way I find to decide, in an experiment you're reading and you have to identify which of these is the independent variable, which is the dependent variable. So what I often do is say, put your sentence into a very simple, what controls what? So, for example, going back up to Roger's statement, we have two variables. We have the taking honors courses and the college dropout rate. So if I were to put them into a sentence very simply, what controls what? Does it make sense to say that taking honors classes controls college dropout rate, or college dropout rate controls taking honors courses? Which one sounds better? My hope is that you decided the first one, where taking honors courses controls the college dropout rate. In any scenario, whatever variables would be put in there, we have many more examples. Whatever you say first, that is the independent variable. Always works out that way. Sorry, I spelled that wrong. In the second, whatever comes afterwards, that is the dependent variable. So I can then conclude in Roger's example that taking honors courses is the independent variable. What I don't have control over is the college dropout rate. So that would be the first and kind of simple example of what controls what. So if we look then at another example, let's decide what the independent variable is and what the dependent variable is. In 1927, Hermann Mueller developed an experiment where he exposed mice to X-rays. Consequently, these mice showed mutation rates higher than those not exposed to X-rays. So let's simplify this into saying what he did is he has two things. He exposed X-rays, so that's kind of one of our first variables, and mutation rates. So let's put that into a simple sentence. X-rays control mutation rates, or mutation rates control X-rays. Which one sounds more logical to say? X-rays control mutation rates. So because that is the case, that's going to be our X-rays will thus be our independent variable. Our dependent variable will be our mutation rates, because the X-rays control those mutation rates. Once you have your data, all right, what we're now going to do, sorry, I have to renumber that. This is the fifth step. What we'll now do is analyze our data. So the most common way to analyze data is to construct some type of physical representation of the data. Most often in this class, you'll be doing graphing. So what we'll do is we're going to talk about some decisions you have to make before you can even start graphing. The first thing is, when should I decide to do a line graph? When should I do a bar graph? So a line graph is for observing a trend. If you notice that after you're looking at your data, that you notice that the variables have a correlation, that one is controlling another in a very predictable manner, then you're going to do a line graph for that data. If what you're doing is a bar graph, you do that when you're doing a comparison. So if you are comparing towels and how they absorb with the absorption rate, a comparison graph is a bar graph. You want to do a line graph with that. So bar graph, comparison, line graph, observing a trend. How do I know which goes along the x-axis and y-axis? The x-axis is your horizontal axis on a graph, and your y-axis is your vertical. The x-axis is going to be the independent variable. So that goes back to understanding, can I identify which one is the independent and dependent? If you can't do that, then you're somewhat going to be messing up your graphs as well. The y will then be the dependent variable. So that's an important question to ask yourself before you start constructing your data. What information should be included in the title? In this class, you are never to type a title as having verses in it. So you've got to make sure that your title has both the independent variable and the dependent variable present in it. So it might often start with the effect of altitude on the temperature. You know, you can see those two things. It's a cause-effect relationship. So what we'll do is I'm going to stop here because I have a 15-minute limit. on videos. So what I'll do is I'll pick up the next thing in the next video.